Welcome back. We're in week 7 and this is lesson 3. In our third lesson, we're going to look again at the binomial probability distribution, and this time we're going to look at some nice, easy ways for finding the mean, the variance, and the standard deviation in a given probability distribution, binomial probability distribution. Okay, when we talk about binomial probability distribution, one of the criteria is that we have a fixed number of trials. And we call that fixed number of trials n. So n, that equals our fixed number of trials. How many times we're going to try a procedure and get one of two possible outcomes. The next thing that is required for binomial probability distribution is that there is with actually 4 criteria, but one of the other ones is that the probability for a success is constant. Okay, so this is, P represents the probability of getting a success in any given trial. And Q is also a constant. That is the probability of not getting a success or of getting a failure in any given trial. And it's important to remember that Q is actually equal to 1 for 100% minus the probability of a success. 1 minus P is Q. So something to keep that in mind. Okay, so what we're going to do is we're going to first start with finding the mean. To find the mean, and I'm going to use population here, but well, if it's a sample, we could use a sample. In this case, we'll consider population. So the mean, mu, if something is a binomial probability distribution, the mean is simply equal to n times p, the number of trials times the probability of each individual trial. The variance is also fairly simple, and our symbol for population variance is sigma squared, and the variance is n times p times q, the number of trials times the probability of successes times the probability of failures. And lastly, the standard deviation. The standard deviation is denoted for a population by just sigma, and the standard deviation, of course, is the square root of the variance, the square root of sigma squared, or you could write it as the square root of n times p times q. So these 3 easy formulas give us the mean, the variance, and the standard deviation. And what is really important here is our range rule of thumb, which you've seen in the past. Our range rule of thumb. This is where we would expect our outcomes to occur. Range rule of thumb basically tells us that we would expect our outcomes to fall somewhere around the expected value, which is mu. Let's put that in there. Mu is our mean. Mu is our mean, and also considered the average or expected value. But it could be a little more than or a little less than the mean or expected value. And the range rule of thumb tells us that it would depend on the standard deviation. The standard deviation, and that we would expect our values to fall from up to 2 standard deviation above the mean or 2 standard deviation below the mean. So that is, the range rule of thumb says that our expected x value, our outcome, would be somewhere between the average plus 2 times the standard deviation and the average, or the mean, minus 2 times the standard deviation. Anything outside of that would be considered unlikely, improbable. Okay, so let's try these out. We have a jelly bean vendor. Let's read the problem. Whenever doing a word problem, read the problem a couple of times so you can wrap your mind around it and then start writing out your facts. Here the problem says, a jelly bean vendor claims that approximately 30% of the jelly beans in each jelly bean bag are green jelly beans. Is it likely, this is a question, is it likely that a bag of the vendor's jelly beans will contain 40 green jelly beans out of a total of 50 jelly beans? Okay, so we're saying that we're looking at an outcome of 40 green jelly beans out of a selection of 150 jelly beans, when the probability, according to the vendor, is that 30% of the jelly beans in a bag will be green. Okay, so let's write down our givens using our variables from the previous slide. N is the total number of jelly beans in the bag. There are 150. Well, the outcome is actually that we found 40. And our question is 40 reasonable? So we're not going to find the probability of 40 at this time as we did in the last lesson. Instead, we're going to find the mean and standard deviation. So what is the probability of getting a green jelly bean, which is a success, P? It's 30%. And the way we write 30% here is 0.30. So the probability of not getting a green jelly bean, which is a failure, would be the remaining 70%, which we write as 0.70. Okay, so what are our facts that we're going to work with? Well, N is 150, and P is 0.3, and Q is 0.7. So now let's go ahead and find our mean, or average, or mean or average or expected value for the population of 150 jelly beans in the bag. Well, the formula for the mean is N times P. Then N is 150. There are 150 jelly beans. And the probability of getting a green is 0.3. So we're going to multiply 150 times 0.3. We know 15 times 3 is 45, but sure, you can certainly put this into your calculator, 150 times 0.3, and you're going to get 45. So 45 jelly beans is the expected value of jelly beans out of a bag of 45 green out of 150 in the bag. Now let's find the variance. The variance is N times P times Q, or 150 times 0.3 times Q, which is 0.7. Well, we already found the 150 times 3, that's 45. So we just need to multiply 45 times 0.7, or 0.70. So if we take 45 and we multiply it by 0.7, and I'm using my calculator, I get a 31.5. Okay, that's the variance, and I want the standard deviation. Well, the standard deviation is the square root of the variance, which is the square root of 31.5. So let's use the calculator again and find the square root of 31.5, and I get 5.6. So my standard deviation is 5.6. So I'm going to now take my mean, which is 45, and my standard deviation to find out the range of values that I would expect using the range rule of thumb. So here's my line. This line's going to indicate my range. The center is going to be my mean, and my mean is 45. I'm going to move 2 standard deviations to the right and 2 standard deviations to the left. Well, here I want to find what is my mean plus 2 times my standard deviation. That's going to be 45 plus 2 times 5.6. I'll put this into my calculator. 5.6 times 2, and I'm going to add that to 45, and I get a high. My range can go up to 56.2. Now, down below, I'm going to take my mean. This is the lower end of my range, and I'm going to subtract 2 times the standard deviation. That is 45 minus 2 times a standard deviation of 5.6. So 45 minus 2 times the standard deviation of 5.6 gives me 33.8. So I would expect the number of green jelly beans to fall somewhere between 33.8 and 56.2. And in this particular case, the number of jelly beans I have, let's circle them up here, is 40. And sure enough, my 40 jelly beans, well, they fall somewhere in here. So I would say, yes, this is likely. So this is the range rule of thumb that allowed us to make that educated guess. And yes, this is actually statistically likely that there would be 40 green jelly beans out of 150 if the vendor claimed that 30% of the jelly beans were in each bag, or approximately, were green. So this concludes our last lesson for this week, and there should be some homework, and if you have questions, please feel free to email me or add it to the discussion board under questions.